Hello, today's video will cover basic probability rules, which is lesson 4.2. Our objectives for today are for you to be able to give a probability model for a chance process with equally likely outcomes and use it to find the probability of an event. We want you to be able to use the complement rule to find probabilities and use the addition rule for mutually exclusive events to find probabilities. So let's start with a question. We learned in section 4.1 that probability describes what happens in many repetitions. If we wanted to know the probability of rolling a fair die and getting a 2, do we need to roll that die hundreds or thousands of times to calculate the probability? Thankfully, the answer is no. We can do this in a more theoretical way. We can do this by creating a probability model. Let's look at what happens if we roll two fair six-sided dice. We're going to keep track of those dice by just saying that one is red and one is blue. And we're going to develop a probability model for that process. So if you look to the right-hand side there, we've got all the possible outcomes that can happen if you roll both a red and a blue die at the same time. Because the dice are fair, each of these 36 outcomes will be equally likely, and each will have a probability of 1 out of 36. So instead of rolling two dice thousands and thousands of times and keeping track of all of those results, instead, if we spend some time just putting together a model, that will help us calculate these theoretical probabilities. So, some definitions. Probability model and sample space. A probability model is a description of some chance process that consists of two parts, a list of all possible outcomes and the probability for each outcome. So if we go back to our previous slide, we've got here a list in picture form. A list can come in picture form. It doesn't have to be a list of words. So we've got here a list of all of our possible outcomes if we roll two dice. It also contains the probability for each outcome. Well, there were 36 outcomes here, and because the dice is fair, they're equally likely, so each of these rolls has a probability of 1 out of 36. The list itself, just the picture here, is called the sample space. The list of all possible outcomes is called the sample space. If we have this probability model that has my list of all possible outcomes and the probability for each outcome, it allows us to find the probability of what we call an event. Please pause the video and make sure you've written these definitions down in your notes. An event is any collection of outcomes from some chance process. So events are usually designated by capital letters like A, B, or C. For shorthand, we could write the probability of A as P of A if we want to find the probability of some event A. If all the outcomes are equally likely, which is what we're starting with when we roll two dice or draw from a deck of cards, it is fairly easy to find the probability of an event. Make sure you've paused the video and written the definition of an event. So to find the probability of an event, I want to use that sample space that I've created with that probability model. So it has the list of all my possible outcomes. It has the probability of each one. So let's say I want to find the probability of getting a sum of 5. We can write this as P of A, or I can say the probability that the sum is 5. There are 4 possible ways to get a sum of 5. We could have a 1 and a 4, a 2 and a 3, and then remember we have 2 dice and we have to treat them separately. So we think of that one is red and one is blue. Even if you were rolling 2 dice of the same color, you would still want to think of them as separate dice. So there's not just 2 ways that this can happen. We could also roll a 3 and a 2 or a 4 and a 1. To find the probability, I just take my number of outcomes in the event A. Well, the event was getting a sum of 5. There's 4 ways that can happen, and we divide it by the total number of outcomes in the sample space. And for that answer, I get 0.111. If I were to change that to a percent, it would be 11.1%. So here's a definition with a formula. If all the outcomes in the sample space are equally likely, like when we roll a dice or draw from a deck of cards, the probability that event A occurs can be found by using that formula. Make sure you pause the video now and make sure you write this formula down. So let's talk about some basic probability rules that we know so far, and let's add one. We learned last time that the probability of any event is a number between 0 and 1. All possible outcomes together must have probabilities that add to be 1 or 100%. If it doesn't have that, it's not a valid probability model. Now, when you do this in real life with real simulations, occasionally you'll end up with like your probabilities adding to 0.999 because of rounding. But if you get 1.01 or 0.999, we're going to assume that it's some sort of a rounding problem and say that it's rounding to be 1. Let's add a probability rule. The probability that an event does not occur is 1 minus the probability that the event does occur. You might want to pause the video now and make sure you've written down your basic probability rules. So let's look at an example of this new rule. Rule 3 is the probability that an event does not occur is 1 minus the probability that the event does occur. I want you to think of this as a shortcut. It is not a new rule to add additional work. It's actually a way for us to have less work. Earlier, we found the probability of rolling 2 dice and getting a sum of 5. We found that to be 0.111. To find the probability that the sum is not 5, I do not have to go back and count all of the ways to get a sum that is not 5. These are what we think of as opposites. The probability that the sum is not 5 is the opposite of the probability of the sum being 5. So I can do 1 minus my earlier probability, which is 0.111, and I get 0.889 here. This is what we call the complement rule. We refer to the event not A as the complement of A and denote it by AC. Sometimes the C will be a superscript, a small letter up above the A. This is known as the complement rule. Using the complement rule in this setting is much easier than counting all 32 possible ways to get a sum that isn't 5. The complement rule just says that if we are finding the probability of A complement, we just do 1 minus the probability of A. And remember, A complement is a complicated way of saying event A does not happen, not A. So if we go back, the complement of getting a sum of 5 is that the sum is not 5. Again, there's sort of like opposites here. Mutually exclusive events. So this is an important concept when we use probability rules. And I want to use some M&Ms to describe what this means for something to be mutually exclusive. Suppose you open a small corner of a bag of M&Ms. You pour one candy into your hand and you observe the color. According to Mars, who makes M&Ms, the probability model is below. So it looks like that red and brown are the least likely colors to get, while blue is the most likely color to get. This is a valid probability model. It includes all the possible outcomes along with their probabilities. The probability of each outcome is between 0 and 1, and if we add all the probabilities together, they equal 1. All of these things need to be true to have a valid probability model. What's the probability that you get a green or a red M&M? So remember, I'm just dumping out one M&M into my hand, not two. But the event that I'm looking for is it could either be green or red. We can just add these probabilities together. The probability of green or red is just adding the probability of green plus the probability of red. So I do 0.16 plus 0.13 equals 0.29. So I have about a 29% chance of getting either a green or a red. However, this rule only works because I cannot get both a green and a red at the same time. If I'm dumping out one M&M into my hand, I'm only going to get one of those colors. These events are what we call mutually exclusive. There isn't an M&M that's both green and red. They can't happen at the same time. So let's get our addition rule down. This rule only works for mutually exclusive events. That's important. So two events, A and B, are mutually exclusive if they have no outcomes in common and can never occur together. That is, if the probability of A and B together is 0. The addition rule for mutually exclusive events says that we can just add our probabilities together. Remember, this only works for mutually exclusive events. For example, our M&Ms. I can't get both a green and a red M&M at the same time if I'm just drawing out one M&M. We will develop a more general rule later that works for any two events, even those that are not mutually exclusive. So at this point, are you able to give a probability model for a chance process with equally likely outcomes and use it to find the probability of an event? Are you able to use the complement rule to find probabilities? And are you able to use the addition rule for mutually exclusive events? I would add an additional one here. Make sure you understand the concept of mutually exclusive and make sure you come to class ready to ask questions if you have concerns about any of these. See you in class.